Good afternoon, Jan.
Michael, good morning.
How do you do, sir?
Doing fine. What about you?
Yeah, doing pretty well. Getting ready for the Vegas trip next week. Yeah, and just just having a good time with uh, all sorts of different things going on around the edges.
Mm.
Yeah, but of course, the
So, yeah,
main thing is Janaga. But yeah, there's stuff happening at work. There's
yeah. It's not different over here. Uh, a lot of good things happening. So
hmm
life is good and well.
Yeah, it's kind of funny. One of the things that I've been working on for improving is a bid for a brand new client, and the product that they want to build bears some striking resemblance to what you have built and are hoping to rebuild with Janaga.
Ah,
So
okay.
so it's like, oh, you know what? I've got a secret weapon that could make this. But
Yeah.
no, I'm being responsible and I'm specking it out according to the traditional ways of building software. Instead of saying, you know what, we could cut this down to
Mm.
25% of the effort. Well, yeah, it might be a little bit extreme, but
But that would be
maybe,
nice.
yeah,
Uh,
have to
if the
measure that first.
yeah,
Mm.
if the bit in the traditional way is 4 times more expensive than
Mm-hmm.
Michinaga. But okay, let's be
Yeah,
careful first.
exactly.
And
Yeah.
once you make a quotation, you have to deliver also.
Yep.
Um,
Yep.
and
That's
things always takes more time than expected.
yeah. And most likely, it's not going to be
Mhm.
me who's on the hook to actually deliver. So I'm just putting
Yeah.
together the estimate.
Mm.
I've already got a client,
Yeah.
and not
And
looking to end that relationship in order to start this one. So
mm.
I'll entrust
No,
this
and
to somebody else.
okay. Um, yeah, I saw there was somebody new on the,
Mm-hmm.
but yeah, perhaps he will.
Yeah. So we've got Luis
Yeah.
and George have
Mm.
both attempted to join.
I saw one name. Somebody who was reading the book already.
Yeah. George
Yeah.
says he's already doing some reading,
Hmm.
which is excellent. Yeah, I think it was
He might,
Luis who tried to join last time and saw that we were talking
mm.
and said, "Oh, I'm interrupting." I said, no. This is what this is all
Yeah.
about.
Hmm. Good, Michael. Thanks to your explanation, the few pages that you wrote, and
Mm-hmm.
then actually what I try to put a little bit all the resources that we have now,
Mm-hmm.
because in the end you get so many resources that it gets too much to see together. But at one end we have the .NET implementation of the memory store.
Mm-hmm.
On the other hand, we have the Postgres implementation in Jinaga Server. So that's the real
Mm-hmm.
SQL for database. And then we have, I call it three tools. We can run the tests in Jinaga Server
Yeah.
from this Postgres read spec. That is quite interesting. We can run the specifications with the Jinaga link
Mm-hmm.
language.
Yep.
Yeah, that's what I call it, Jinaga link.
That's
Um,
accurate. Yeah.
we can call it in VS Code from the Jupyter environment. And we can also run specifications from Postman.
Yeah. Yeah.
So we
All
have, in
those options.
fact, we have all these options.
Mm-hmm.
Um, it took me a while to get them ordered in
Mm.
first on paper and then in my head, um, because it puts together a global overview of how it works. The clouds are getting to get it away a little bit, I see a little bit sunshine in how it works. So actually in .NET, we will go the part from the Jinaga link into the specification language
Mm-hmm.
that is already existing.
Yes.
Yeah, that's what you built.
Yes.
Now, then the next step is to go from specification language, but there we just take the specification class structure with givens, with matches, with projections, and that we feed into the the equivalent of the read command in the JavaScript.
Exactly. Yes.
Yeah. So that specification structure, and then we will build a SQL out of that.
Mm-hmm.
Is
Yes.
that okay?
That is correct. Yes.
Okay.
Yes. So you can ignore
And
feeds.
yeah,
Just look at read. Yes.
yeah. And in fact, so the part that we need is actually what you wrote in that document,
Mm-hmm.
where we make the query description. And so we all the different SQL and we compose them together.
Yes. Yes.
Okay.
Exactly.
But then there is still something that is still, but then that has nothing to do actually with the query itself, but it keeps bothering me. The feed in the drawing, that roadmap drawing,
Mm-hmm.
you know which one I meant?
I do. Let me go ahead and get that queued up so that we could look at it together. Okay. So that was in. Yeah, actually, that is uh, on GitHub. So let's.
Oh, I should have.
Believe that is janaga.net.
Yeah.
And then we've got. Yeah. So that is within the README. Okay. All right, I can do a quick screen share so that we can all be looking at the same thing.
Yeah, I just.
Okay.
So there we have these feeds, and I'm still in doubt why we need it, because at a certain moment you said, okay, we need a feed for the positive facts,
Mm-hmm.
but then we need a kind of tombstone feed
Mm-hmm.
where you in fact get the deleted facts. But historical modeling, in fact, there are no tombstones, because a deletion is always adding facts.
Mm-hmm.
And that was the big advantage of historical modeling. You want to sync, you just have to add facts. So why do we need to separate
Yeah.
the delete facts and the other facts?
Yes. Yeah. Good question. Let's.
Am I completely misunderstanding it?
Um. I. I think it is just a detail to kind of nail it down. So, let me pull in. Well, this example doesn't really illustrate it very well. Just trying to save some time by going to an existing example that has. Okay, there's. Well, that's mutable property. Um, okay. Yeah, yeah. Here we've got an example. So, yeah, a student can drop a course. Okay. So, if yeah, let's suppose that that um, we've been running the this application, the student registration application, for a little while, and
Yeah.
so we've got some students in there, some registrations for some courses, and in the past, students have dropped courses, so we've got those drop facts in there as well. Um, if I run courses for students and um, and I project the results. So for this one particular student, I'm looking for all of their registrations that have not been dropped. Um, then um, then I won't see any of the past courses that they have dropped.
Do you have the model of this one graphically somewhere? Because
Yeah,
I'll
yeah,
just render it.
yeah. Let's
Um,
do that. So bring that in.
because that might be easier for me to follow and for others as well, I think.
Yeah. So Jinaga GraphViz renderer, render types. So I want the certainly want the drop. Let's see what that gives us so far. Um, yeah, yeah. I think that's the part of the graph that we're looking for. So
Make a print screen out of that and I can put it on my other screen. Why is this so slow? So many print screens in a directory that it's slow.
mm-hmm.
Windows Explorer is getting slow. Incredible. My computer is like
Right.
historical modeling. You never delete things, you just add things.
Yeah. Okay. Yeah. That looks best. Okay. So yeah, we've been running the application for a while. We've got students in the history. We've got courses that have been offered in the history. Students have registered for those offerings, um, and so a particular student that we're interested in has dropped some of those registrations. So they never actually took the course; they just registered. They dropped, um, and so now we come back and we're looking for a particular student. I want to find all the registrations where there does not exist a drop,
Okay.
and then show me information about that course. So that's what courses for student is all about. So so yeah, when I get all of that information, I get only the registrations that have not been dropped. So so a particular registration that happened in the past that also has a drop associated with it won't be returned in any form whatsoever to my client. So uh, so I won't know about those registrations. So that's the happy path. That is what you are. I think what you were thinking about when you say, okay, we don't need the feed because I've got the correct information. Um,
Yeah.
so now let's consider a different scenario in which yeah I've history's been accumulating. I run the client, and this student is currently registered for the offering of a course. So this registration exists, and then the student drops it, and I run my client again. So the student has just created this enrollment drop, and now my client is interested in all the registrations that have not been dropped. So um, so there's nothing that my client is telling to the server, to the distributor, that tells it that I'm interested in that drop fact. So I'll know about the registration. I will never learn that it's been dropped if I just run the read query. So I filter out those dropped registrations.
Yeah, but why can't we just get all these drop facts at the same time as the registrations?
Yeah. Yeah. So the way that we get facts at the same time is that you receive a feed of tuples, and so a tuple um, contains multiple facts at different points within the graph that all have the same shape of relationship. So I might get a tuple that says, here's a student registration uh, for, and then I might go all the way up to the course. So student registration and course might be the three facts that are in that tuple, because those would be the three labeled facts here. So I've got, like here I've labeled offering, um, but yeah, I might have decided not to label offering and just gone straight to the registration. So I get those labeled facts as part of that tuple. There is no label um, in this level of the query that represents the drop. The label for drop is nested. It's inside of this where
Yeah.
clause. So so that means the feed that has the student registration course tuple does not contain the drop facts at all. Um, so we create another feed that does contain student registration course and drop. So every time you go into a where clause, you create a new feed that adds that new label to the tuple.
Okay, but so in the end, all these facts, they just get mixed up again in the database,
Yeah.
in the local database.
Yeah, exactly.
Yeah. The fact that we do it in different feeds is only because it's more logic and easier to do it that way.
And one other reason that we separate it is that the student registration course feed, that the feed that just has that three tuple,
Mm.
since we have filtered out the dropped registrations, um, uh, there is no way that we could put drop into that feed. So it's already part of the existential clause. We don't want those registrations, um, and so even if we were to say, okay, let's collapse it into one feed, now that feed can only contain the dropped registrations because it has to have a drop fact in that tuple.
Yeah.
Yeah, and that is to make the future clients happier, so that they don't have to read all of history, including the dropped registrations, and then learn about the drops and filter them out. Um, because we can filter a feed, we can say this one only contains the drop registrations. Then at some point in the future, when you actually drop a registration, then we have removed something from that feed. So
Yeah.
future clients will skip right past it. Um, so
And the
yeah.
future and these future clients, because they don't get the dropped registrations, they never need the drop fact to come in.
That is true. They never need the drop fact to come in. Although, because we're doing two feeds, they will actually see the drop fact.
Okay.
Yeah. So yeah. So the real part of the optimization comes when you've got more stuff, more successors on registration. So
Mm.
so if you've got so if they then actually um, take take that course, so maybe they audit it for a few weeks, and so you've got maybe some attendance related to that registration, or some even some test scores, and then
Yeah.
they figure out, okay, this isn't worth for me, and I drop it later. Then adding the drop fact, you would want to have the effect of not showing you any of that other related history that you will never care about. And so this way of creating the feeds does exactly that. So
Yeah.
so yeah, those feeds that have the test scores and the attendance will include this existential condition. So so if you are joining the game late, you will never see that those test scores or or that attendance. You will
Mm.
see that registration has been dropped, and then by inference, you'll know about that registration, but you won't know about any of its other successors.
Yeah. Mm. But
Yeah,
actually, that means that somebody who comes in late, he doesn't have the full history.
exactly, exactly.
Yeah.
Yeah, not the full history, but it does know enough.
Mm.
It knows about the drops, um,
Yeah.
and it knows about that identity. There was a registration, just didn't know any details about it. Um, and so that means that if some other peer, we're not making any assumptions about the topology. We don't assume a hierarchical topology or a star-shaped topology. So anybody could actually tell you about facts at any time. So if somebody does happen to tell you about one of these other facts about this test score over here, you already know that registration has been dropped. So you already know you don't care.
Yeah. Indeed.
Yeah, these are the little edge cases that I actually missed when I was doing the first you know
Mm.
the first pipeline in Jnaga.js, and corrected them in the book, but did that in a pretty complicated way. And
Yeah.
even though this sounds complicated, when you get right down to it, the fundamental operations that it's performing on those feeds is pretty straightforward. Um,
Mm.
so the proof of correctness actually falls out of the way that it builds the feeds.
Yeah. Okay. That is clear.
Excellent. And there it is. Okay. Cool. Yeah, there's a lot happening in that code, but yeah, yeah, hopefully the stuff that like what we just talked about with the feeds. I mean, that's not in the code that we need for this operation in Janaga.net. So um, yeah, so
But it
hopefully we'll be able
but it
to
helps.
ignore certain things and
Yeah.
yeah.
Yeah, but it helps to understand. So if the interface is not clear,
Mm-hmm.
um, and I kept looking at that picture. I say, no, that's not possible. Yes, it is. Good.
Yeah.
Um,
Excellent. Well, I had a couple of small fixes. So uh, what I've what I've been doing is um, there's so take it all the way back to the Improving You application, the first Janaga application ever built and still running. The over 5 years of it's probably closer to 7 years of history, um, and uh, and so we are currently at Improving in the process of creating a a new unified platform that takes care of all of our internal programs. And one of those internal programs is Improving You. And
okay.
and so in order to import data into that platform, um, I've been talking with a gentleman by the name of Carlos to show him how the Improving You application stores its data. Um,
Mm.
we eventually got to the agreement that we will continue to actually run Improving You out of the Improving You application, but just aggregate the data so that we can see all of an improver's activity all at the same time. So, um, so that's the process that we're working on. And so at first I showed him the specification language. So with Postman, I said, okay, let's put together this, this query. All right, let's hit the read endpoint and let's see the results. So okay, now you can export that as JSON. You can bring that into your application. Um, so of course, when you do that, all of the questions about well, what if somebody does this? What if that happens? So I've already imported a course. Somebody changes the title of the course. How do I respond to that? And that just gets you into the conversation about well, you actually need to have not a snapshot but a history, and we can start talking about feeds and all that stuff. Um, but uh, but I think uh, so that's kind of when humans do that, we get confused. Things are complex. Oh my goodness! Somebody tore down the Space Needle. It's a good thing I don't have my Klein bottle up there anymore because it would be broken now.
Yeah.
Yeah, it's safely in the closet. Um, but yeah, so we start having that conversation, and it's like, okay, this is starting to get too complex. I'm going to tap out. I'm just going to import the data, and if something happens, then we'll go in and fix it. That's the usual response to that. Hopefully, one of these days, it won't be an issue, and then people won't have to make that kind of a compromise in order to be able to simplify things. But so we've gotten to the point where he is reading the JSON out of the read endpoint. So the one that's intended for humans, he's actually using for data integration. Okay. And so I demonstrated to him now that that you can take the and this new system is written in C#. So rather than make this this call to this read endpoint and then parse the JSON and do all that stuff, here is a set of records. You can just run some link queries and you get back the results.
Yeah.
So so even though he already finished the data import, he said, okay, there's probably going to be some more stuff we need to come back and work on. So we'll keep that in our back pocket. But in the process of doing so, I did discover another bug. So I got that one fixed this week, and shared that fix with him. But yeah, that bug was based on an old defect in Janaga.js, which I eventually fixed, but the data left over from that defect was still in the database. And I never went back and cleaned it up, specifically because of this reason. I want to be resilient against bad data. So I don't want to rely upon the fact that my peer is doing the right thing. I want to be somewhat protected. And so this bad data was that we had a fact in the database whose predecessor was not in the database.
Okay.
So it's like, here's a fact. Here's the hash of my predecessor. Look it up. That hash nowhere to be found.
It's not there. Yeah.
So so yeah, when I was demonstrating it to him, I said, okay, and look, you can go through all of history and you can get all of the titles of the courses, and then throws an exception. I said, I know what that is. But yeah, now now as it's pulling that information together, it is it used to well, in fact, I can share this. Let's see, this one would be there we are. Okay. Yeah, so in this one, this is in the fact graph. There we go. Okay, so um, so it used to be that that right here it would check to see do do I have all of the predecessors of this fact already in this graph? And so this is happening, for example, when you do an HTTP. Oh, now it's going through the builder. Got a whole bunch of tests around it now, of course. There's the HTTP. So so we do the load. So this is we already now have a bunch of fact references that I know are not in my database. So I need to load them from the replicator, and so it's going to call load using the web client on that replicator, and then it's going to get back a whole bunch of facts, and so last week the replicator was returning these facts in just some arbitrary order that I happen to have them in. But then I said, oh, the replicator should topologically sort them. Let me fix that. So now they usually come back topologically sorted. However, in the case of the fact that doesn't have any predecessors in the database, it's still trying to put them in topological order, but the predecessor is just not there. So so you add it to the fact graph, and then it runs into that exception. So, oh, I'm already there. Oh, there we go. So, yeah, I still have this this not can add. I just kind of took this this condition and factored it out so that you can see it from the outside. So, still doing that while you're trying to add facts to the graph, but now there's something else on top of it that's kind of guarding it. This is basically how I like to implement design by contract. I think it's in the spirit of Myers. Oh goodness, what was his name again? Anyway, Meyer. Yeah, Bertrand. Not Bertrand Meyer. Is it Bertrand? Yeah. But yeah. So if you have a fact graph, then you know that the fact references collection is in topological order, and you can rely upon that. And you know that it is a complete graph. All of the it is closed. All of the predecessors are there. So I wanted to be able to rely upon that later on in the code. So so add enforces that, and it throws an exception if you can't add. So the new thing that I put in place was this fact graph builder, which which understands that contract. It understands that I'm not allowed to call fact graph add if I can't add it if the predecessors aren't there yet. So instead, what it does is it puts that fact in reserve, and then
and it will keep it until you have all the predecessors.
Yeah, that is the hope. It doesn't actually know that you will eventually get those predecessors. So so then when you want to actually build the fact graph, this is when you're saying, okay, fact graph builder, I've given you all the facts that I can. Now it's time for you to do your work and build that fact graph. If there's nothing in reserve, then we've already got the fact graph. We just return it. But if there are any in reserve, then I pull that collection aside, call that retry, and then I clear out the reserve collection. And then I say, all right, try these again. Um, and then I keep doing that until I go through everything in reserve and nothing ends up in the graph.
Yeah.
So if I add everything and everything ends up back in reserve, then I know, okay, I've um, I've missed some predecessors and I can't add these. And so we just give up at that point. But yeah, if you give it facts that are out of order now, then it will hold them in reserve until it sees the later ones, and then go back and try to add those.
But this reserve is just structure in memory. It's not saved to disk, to database.
Correct. Yes.
So if you reboot your application,
Yeah. Yeah. If you reboot your application, then you're gonna load those facts again from the database and run it back through the fact graph builder in order to get a graph out of it.
yeah.
Yep. So I suspect this is a pretty dumb and inefficient algorithm, um, unless everything comes in topologically sorted and you can just skip over this step, which the most of the time should be coming in topologically ordered, because now I'm ordering it topologically on the replicator. But yeah, if it does come in out of order, if it comes in exactly reversed, then and you've got a
It's easy.
string of facts, then it's going to be the worst possible. Go through everything until, oh, I can add that one. All right, now go everything. Oh, I can add the last one. Yeah, and reverse the order. But yeah, that should not happen very frequently. But yeah, I still would like to measure the performance of this and make sure that it's not adding too much overhead in those rare cases that have got bad data.
But it keeps things in memory. So if it gets too much bad data, that might lead to issues.
Yeah. Yeah. In fact, even the fact graph itself is in memory. So that is just a dictionary of references to facts and the list of facts in topological order. So so this is there's a lot of duplication here. You've got those same fact references as the keys to the dictionary and the topological order, and furthermore, the fact contains its own reference. So you've got a third duplication of that fact reference structure. So that is the type in the hash. So yeah, not terribly memory efficient, and so the way that that you try to protect your client's memory is that before you get to load, you've got a limit to the number of fact references that you can be pulling back. And that's because, let's go back to the yeah, it's a manager. It is the network manager. Yeah. So, oh, and this was another defect that I found during this whole process. I actually found this one last week. We just didn't talk about it. But yeah, as you are fetching from a feed, it is. Let's go to the. Yeah, is it that one? Let's see. That's local network. Yeah. Okay. So web client feed right here. Oh, okay. Actually, it is on the on the replicator side. So there is a limit on that gets stuck into the SQL query. So when I run a SQL query for the tuples within a feed, it's going to limit the number of tuples that it reads. And so by the time you get out here, you basically flatten that that set of tuples down into a list of references, and so now you are getting some bounded set of fact references. So when you turn around and say, okay, I only want the ones that I don't know about, so I remove the ones that are known from that list of fact references, and then I do my my load. Now I'm getting a page of references.
Yeah.
So we can tweak the behavior of the system by changing that page size in the replicator, and seeing that it respects memory limitations on the client. Yep. Which actually segues nicely into the bug that I fixed last week. In here, I didn't have this. So I was going through all the different feeds in order to satisfy this specification, and grabbing the bookmark and then doing one fetching one page, and then going on to the next feed.
So you didn't have all the information loaded.
Right. Yep. Yeah. Yep. So I'm going through and I'm demonstrating to them. Look, you can look up all the information about this course. You can look up all the, So for very small scoped queries, it was doing great. And I said, okay, now let's turn it loose. Let's see all of the courses for all semesters across all. Just do everything starting at the company, and then of course that created a set of feeds, and some of them had multiple pages of data, and then it comes back and it's like, this is wrong. There's not enough information. I'm not getting all the student registrations in this case. So so yeah, there's something missing. And then stepped through and looked at it's like, yeah, it's generating the right SQL. It's doing all. Oh, it's not coming back through and looping until it comes back with no more new facts.
Oh, but that's the advantage of testing.
Yeah.
With real data. If you just look at it in theory, you will always forget things.
Yep. Yep. And I've got a lot of unit tests here, and all the unit tests pass, but yeah, I didn't have a unit test that had sufficient data to go to the next page.
Testing is difficult.
Yeah, it is.
To cover everything.
Yeah. But one of my favorite things about this whole process is that I have confidence that I'm going to see each one of these defects exactly once. Because once it's fixed for all applications. We are far below the threshold of knowledge about the application.
What do you mean by that?
Yeah. I don't know if this code is going to be used in DWS, or if it's going to be used in some other application, or it's going to be used in Improving You. So yeah, all that information is above this code, and it's all been erased and just turned into this specification object. So
okay.
So yeah, I know that if I give it complex enough specifications that I can actually test through all of the different scenarios in here, then I know that, or I have confidence at least, that somebody can come up with their own specification for their own application, and it will still work. It'll still do the right things.
Let's hope.
Yeah.
It should. It should.
Yeah. Yeah, because I'm coupling this with the mathematical proof.
Hmm.
Um, so yeah, I know that as long as I've written this code correctly, I
Hmm.
can then say this code expresses this intent, and now I write a proof with that intent. Um, so if I manipulate specifications in this way, then they have these benefits.
Hmm. Now, once we start building real apps with this framework, um, we will quickly find out where the data is missing, I think.
Yeah, yeah, I think so. Okay, yeah, I think there was one other. What was it? Oh yeah, yeah. There was one other thing that came up that I have not yet addressed. So let's go back to yeah in here. So this is um, the improving you model that I've shared with Carlos.
Yeah.
In fact, I've just taken this this source file and stuck it into a console application and said, all right, just yeah, you can start running yeah
Mm-hmm.
running queries against this. Um, and so I gave him uh, some relatively simple examples, like this one here gets all of the titles for all courses um, offered in all semesters in all offices. So starting at the company, just give me the semester, the catalogs in that semester, um, and then all the courses in those catalogs. And and so yeah, we talked through this one live, and this worked pretty well. Um, then it was with some others that we uh, had some of the issues. Um, and this one here, attendance specification. This this answers a very specific question that we want to answer for uh, for our KPIs. We want to know at each office um, how many distinct improvers are participating in improving you.
Mm-hmm.
So um, so the way that we did that, actually, I will render out this model so that we can discuss that. So bring that in,
Mm-hmm.
bring in the Janaga client, bring in the model, and so here I'm going to Janaga graph viz render types, and I want the type of course registration, I think it's called. Okay,
There
so
we have it.
um, yeah, so this is a particular student registering for a course. So similar to the model that we looked at before, um, but not quite as refined. Um, so um, so we're looking for course registrations, but we are also looking for um, sessions. And in fact, I'm going to go all the way
Mm-hmm.
down to student attendance. Okay, so um, so we have an Improving You course, which is a specific offering. So it is
Mm-hmm.
that in this particular semester, this particular office catalog introduces the office. Um, we are offering this course, and so um, students can register for that course, and then uh, we uh, we have different sessions of that course. So if it's
Yeah.
a 3-day mass transit course, you register once, but then there are 3 separate sessions, and then we've got an attendance sheet per session where we keep track of the student attendance. Um, so student attendance is
for that particular session. Yeah.
Yeah. Yep. So we're not terribly consistent about taking attendance. Um, even though I built the system, I forget to do that all the time as well. Um, so so we have to make an assumption when we write this KPI. So if we don't have an attendance sheet,
And everybody was there.
Yeah, then everybody who registered was there. So so that leads to a specification like this. So so here we're starting at a specific semester, and then looking at all the courses and then all the sessions. Catalog date is how we can group sessions by date. So we go back up to the catalog date. That shows up right there. So that way we can see, show me everything in this catalog on that specific date. That's to serve up the calendar view. But so that means that's how we store dates. And then now that we have all the way down to the session level, I'm also interested in the registrations for the course. So registration joins back up at the course level. It doesn't care about the session level. So that means that if you've got a multi-session course, you're going to get the same registrations for each one of those sessions. So So my 3-day mass transit course, you're going to get this full block of registrations for each of those. And that's so that later we can do this kind of stuff. So if there are any attendance records, then use that to look for the attendance for that particular student. Otherwise, we say, yes, they were present, because we're going through the registrations in order to get that list. So
everybody who registered, if there is no attendance sheet, then he was present.
Yep, exactly.
Okay.
So so that's why I need the registrations at that level, but I am walking through at the session level. So here's a simplification of that specification that kind of shows the structure that we're looking at. You can look at it in link or in the specification language, whichever one makes more sense to you. But yeah, we're producing this tuple where we've got the course, the session, and the catalog date. But then within that tuple, we're producing the registrations, which just join back to the course, not to the session.
Yeah.
So effectively, this is a Cartesian product. So when I get down to this level, and especially when you think about we're converting this into a feed at some point in order to run this query, the feed that represents the tuple course, session, catalog date, registration, there's the label, that feed has a Cartesian product in it. So it's multiplying sessions by registrations. And that Cartesian product makes it all the way to the database. There's nothing that I do to filter that out, which means that that feed is producing more tuples than it needs to. It would be more efficient if instead of having that one feed, you created 2 feeds. Give me the feed that is the course session catalog date, and then give me another feed that is the course registration.
Yeah.
So that's one of one of my future challenges, it may be a near future challenge because it's bugging me, is to detect that in the specification, and then when I generate feeds, go ahead and split.
Split
Yeah,
it up automatically. Yeah,
yeah.
because now you're getting way too much data. In fact.
Mm-hmm. Yep. Yeah, and I would like people to be able to write any kind of specification that they feel they need to, and know that the system is going to do only as much work as it needs to give you back the behavior you're asking for. Um, in a lot of ways, um, I've designed it so that if you can write it, then it will be efficient. But
Mm-hmm.
but here's one of those cases where that's not exactly that's not exactly true. You can write a really complicated um, specification that ends up being pretty inefficient, but I don't need to make it more inefficient than it needs to be.
Mm-hmm. Well, but in because this is part of improving you, so you're using it.
Mm-hmm.
Do you see any performance problems due to that?
Um, it does take about 2 seconds to run this query when it should take maybe less than a second. Um, but still, I know that this is a query that ideally you just run once a month in order to now report on that
Okay.
KPI. So
Mm-hmm.
um, so practically speaking, it's fast enough. And in
Yeah.
fact, compared to the Janaga.js query generator, this is lightning fast. Um,
Mm-hmm.
in Janaga.js, I do have an endpoint that produces JSON that I used to use to generate these KPIs, and and when you hit that endpoint, it takes 30 seconds to get your JSON back.
Okay.
So
Yeah.
yeah, it was doing an awful lot of work,
Mm-hmm.
and now this is at least offloading that work to the database. And Postgres is
Everything
a little different though.
can always better, but this seems to be fast enough for the moment.
Yeah,
Mm.
yeah, yeah. What's kind of funny is to think back on the kind of the history of improving you and how it's evolved. And it started out with Janaga.js on Mongo, and I thought that Mongo would be a great way to represent a historical graph because um, it is a NoSQL database, but you can kind of think of it as a graph database. But yeah, as it turned out, that implementation was very very slow. For the first couple of semesters, people were just okay, registration is open. Go go look at the list of courses, and then I would get a few
Mm.
people that would be able to see the list, and then everybody else is like, it's not working. Um,
Mm. Mm.
so
And that's
yeah,
where you got to Postgres.
yeah, yeah.
Yeah.
Postgres made a huge difference.
Mm. Because in one of the very old articles that you wrote on one of your old websites, there was an article with a structure dedicated to historical modeling.
Oh yeah.
I don't know by heart anymore what it was.
Mm-hmm.
Uh, I didn't either. I didn't manage to decipher it at that time how it worked.
Uh-huh.
But is that something that you still?
Um, that was the historical tree, and that was part of the correspondence
Yeah.
client. Um, and uh, with uh, yeah, that's something that I have not picked back up um, for the modern Janaga, um,
Mm.
and and so SQL is doing good enough, I think. But yeah, the idea behind that historical tree is that it's coupled with a red-black tree to do the index, but the historical tree directly um, addresses predecessors. So
Okay.
within the data structure, you can very easily follow a link to get to the predecessors, and it takes advantage of the fact that it is append only. So so you add new facts to the tail, and now they've got the indexes that point back to their predecessors already within the tree. Um,
Mm.
and yeah, so I'm starting to remember now why it was so cool. Is that as it built those back references, um, it also put the forward reference into the predecessor so that it could find its successors in a linked list.
Okay. So it could go in both
Yeah,
directions.
yeah.
Yeah.
Um, so it was, yeah, it was a pretty fast data structure. But I think now that, but yeah, if I had stuck with that data structure, um, we wouldn't have made the progress that we have so far. Um, and uh, and there would be friction to changing how feeds work and how the read endpoint works. Um, I would I would be tempted to try to make it work efficiently with that data structure. Um, and now we can actually go back and take a look. Would that same data structure be the best thing to implement the feed query? Um, Maybe, but maybe not. It would be it would be an interesting thing. Or is there a slightly different data structure that does these queries better? Um, and then we can go back and implement those.
Mm.
But yeah, that started out of a necessity because I was working on Windows Phone, and this was before we
SQLite
had
was
SQLite on Windows Phone.
okay.
Yeah, the alternative was to use uh, uh, not Argent. Um, there was a database um, that you know, gentleman who's now actually part of the Entity Framework team. Um,
Yeah.
I'm blanking on his name all of a sudden, but yeah, he created uh, a a database. He created these this file based database
What
that
was
gave
it?
you
Is compact SQL Compact Lite? No, SQL
no
Compact.
no
On,
it had a name that meant silver. Um,
it was not Steve. Steve. What was his name?
no, not
A
Steve
Microsoft.
Dennison.
A Microsoft guy.
Yeah, he is a
Uh,
Microsoft guy now. At the time, he was not.
okay,
Um,
no, he was at the
Sterling.
time. Who
Yeah,
was working on the Sync framework.
yeah. The
Sync
database was
framework in
called
Microsoft.
Sterling. Sterling,
Oh no, that doesn't say me anything.
and uh, and now Jeremy Lickness. That's yeah. And so Jeremy Lickness is now um, at Microsoft. I think he is he's a program manager on the Entity Framework team. I think is his current role. But
Mm-hmm.
yep. Yeah, so at the time I could have said, okay, I'll take a dependency upon Sterling, but Sterling was brand new at the same time that that correspondence, that first version went out. So I was like, okay, I spent a good number of weekends getting the historical tree working. I'll stick with that. Um, and then yeah, Windows Phone died, and
It's amazing history how it goes.
yeah.
Uh, if you see the whole history of all this technology, and then the evolution of Jinaga.
Mm-hmm.
Um, but it's going in the right direction, and that's the
I
thing.
think so. Yeah,
Mm.
yeah. I think we're really close to being able to deploy it
Mm.
to a phone. Yeah. One of the
Makes
other
them,
one of the other next things that I'd like to do is to take the J.Watch uh, API, and so far I've just been testing it, but let's actually use that with Maui and see how that works, and then use that with Blazor and see how that works. Um, I think that it is a pretty generic interface and can be easily adapted to any front end technology. Um, so uh, yeah, I'd like to put that to the test, see if that's true.
to see whether we need what was it, iNotification?
Yeah, yeah. I could already see in my mind how to adapt it
Uh,
to Assistant, which
yeah.
which may be what you end up doing.
Mm.
Um, but
The
yeah,
good
so you
old
could,
assistant.
yeah. But
Mm.
Assistant yet has not yet been adapted to Maui or to Blazor. So there's still that branch. Assistant has the adapter that goes to WPF
Yeah.
and to Silverlight. And um,
Bye bye Silverlight. That's another one which
yep,
went down.
yep.
Okay. No, that was interesting to see how the feeds really work. I can get further from here. Next week, you're out, I think.
That is correct. Next week in
Okay.
Vegas.
So enjoy the trip,
I will.
and we'll be back then in 2 weeks' time.
Yes, indeed. We'll see you then, and we'll see how much I get done on the plane while I'm flying to Vegas.
Now that you have internet with Starlink, Elon Musk Starlink
Mm.
is out for planes.
Ah, okay.
Uh,
I did not realize that.
yeah, yeah.
Okay,
They had an aviation version and kit and approved antennas apparently,
okay.
and so now it is, or it will shortly be available for planes.
Yeah.
So that means they were offering, what was it, 200 megabits per second links to planes, which is
Hmm.
not too bad,
Yeah. That's fast enough for Git.
and which is a lot faster than the current systems.
Yeah.
We will see.
All right.
Okay, Michael, see you in 2 weeks' time.
Yeah, indeed. See you then.
Bye
Take
bye.
care. Bye.